Hello, welcome to this tutorial in which I'm going to have a look at another examination style question on circle theorems. In this particular one, it says P, Q, R and S are points on the circumference of a circle, center O. And the angle QOS, this one here, is 140 degrees. You're asked to find the size, to work out the size of the angle QRS, this one here, and give reasons. And the diagram is not drawn to scale, so you cannot measure the angles and write them down as answers. Okay. At this point, you might want to pause and try the question and come back. There are two methods I'm going to show you. Okay? Right. The first method, if we look at the question, it says P, Q, R and S are points on the circumference of a circle. So what can we say about the quadrilateral P, Q, R, S? Well, it's a cyclic quadrilateral. And what do we know about the opposite angles in a cyclic quadrilateral? Well, they add up to 180 degrees. So the angle that we want to find, which is QRS, this one here, and this angle QPS must add up to 180 degrees. But the question is, how do we find QPS, this one here? Well, if we look at the center, we can see an angle QOS which is 140 degrees. Now a lot of people may think that the angle that we want to find, QRS, I'm talking about this one here, is a half of 140 degrees, and it's not. So the reason for it is because the angle of the center, QOS, is facing this arc here, QRS. Now which angle of the circumference is also facing that arc? Or we say they're tended by the same arc. It's this one here, QPS. So we can say that QPS is a half of 140. So we can divide 140 by 2, we get 70 degrees. And the reason is that the angle at the center is twice the angle at the circumference. Okay? That means we can put in here 70 degrees. So we can now use the opposite angles in a cyclic quadrilateral adding up to 180 to say that QRS, the angle we want to find, is 180 minus 70 degrees, which is 110. And the reason is opposite angles in a cyclic quadrilateral add up to 180. Okay? So what's the other method? Well, if you didn't think about this one, you may have thought of the other one. But if you thought about this one, you might want to pause and think of the other one. Okay? So, the second method does not rely on me finding the angle QPS as I did earlier on. What I'm going to do is have a look at the angle at the center, SOQ. There's a reflex angle there, this one here. How do we find that one? Well, angles at a point add up to 360 degrees. So the reflex angle SOQ is 360 minus 140, which is 220 degrees. Okay? Now, the angle that we want to find is facing the arc QPS, that's the major arc. And so is the reflex angle at the center. So therefore, that 220 degrees, if I just write 220 here, is twice the angle at the circumference if they're subtended by the same arc, which means they're facing the same arc. So I can now write that QRS is 220 divided by 2, which is equal to 110 degrees. So for the first part, the reflex angle, angles at a point. And you can continue by saying they add up to 360. And the second reason is, which I already wrote for you, I've already written for you earlier on, is that the angle at the center, angle at the center is twice the angle at the circumference. There's nothing wrong with using that at symbol. Well, I hope you managed to find both methods. If not, hopefully you've learned something, and I hope you found it useful and helpful. Until the next one, take care.